Now let's talk about the multiplication law of probability. This is the probability that both events A and B, can and do occur at the same time. If A and B are not independent events, then we would want to use this first formula with the A, the upside down U, B, and this would be equal to the probability of A happening times the probability of B happening with A. It's hard to describe how this looks, but in this case, the events A and B are possibly dependent on each other. One event could be dependent on another. But if A and B are independent events, again, they are not happening at the same time, they cannot happen at the same time, then we would want to use this second formula where we would just simply multiply the probability of A happening times the probability of B happening. So an example using this multiplication law, we want to find out the probability of rolling a 1 on a die and picking a king of hearts in a deck of cards. So I know this is a little not a great health related example, but it's the easiest way to get this across simply. The question includes and, so that's our first step. So we know when a question includes and, we're using the multiplication law of probability. And could one of these events is the second step. Could they be dependent on each other? Well, no. Rolling one dice, and rolling and pulling out one card from a deck are completely independent events. They are not happening at the same time. So which formula based on that would we want to use? The second formula. So here in our step 3, we want to multiply the probability of rolling a 1 on a die by the probability of pulling a king of hearts out of a deck. So the probability of rolling a 1 on a die, there's 6 sides to a die, so there's a 1 out of 6 probability of rolling a 1. We're going to multiply 1 divided by 6 by the probability of getting a king of hearts from a deck. So there's 1 king of hearts per deck, so there's a 1 out of 52 chance of getting the king of hearts and out of the deck by pulling 1 card. So we're going to multiply 1 over 6 times 1 over 52. And when we do that, we get 0.003, which we could turn into 0.30% probability of rolling both a 1 on a die and picking a king of hearts from a deck of cards. Here's a more health-related example of using the multiplication law. So we have this outbreak investigation, and we want to know what the probability of eating chicken in the past day and having salmonella is. And in this example, we know that the probability of having salmonella is 4 out of 10, or 0.04, and the probability of eating chicken but having salmonella is 3 out of 4. So that's 0.75. In step 1, we want to see if the question includes and or. If it includes or, again, remember, we'll use the addition law of probability. Since this includes and, we want to use the multiplication law of probability. Step 2, could one of these events be dependent on each other? Well, yes, because you could get salmonella from eating chicken. So there is a possibility that they're related. So we want to use that first formula. So that first formula is the probability of salmonella plus the probability of chicken with that straight up and down line, salmonella. Since we have the values given to us, it would be 0.04 times 0.75, and that comes out to 0.03, which if we multiply that by 100, to get a percentage, we would get 3.0% probability of someone eating chicken and having salmonella.